815, which is titled Graphs, and coming up with a little arrow pointing to an equation. So we're going to look at a graph, see if we can figure out the equation that goes with that graph, and then explain what all the different parts mean. Okay, so what are the connections? Question 866 says graph leading to the equation. Use the clues provided in each graph below to write an equation in the y equals ab to the power of x form. Assume that if the graph has an asymptote, it is the x-axis. Okay, so we've been looking at this form, y equals ab to the x, where a is the what? What number goes in for a? The what? I can't hear you, sorry. The base? No, not. It's what we call the y-intercept. It's where it's gonna start, okay? Or the starting point, or if we're talking about money, it's your initial investment. And then the b is gonna be what? The b is the growth rate. So if you're growing by, if you have money invested in an account and it's at a 6% interest rate, how would you write that? Gentlemen, can you not be talking while I'm talking? Thank you. So if you have an interest rate and it's growing, your number, that's your b, is going to be greater than 1. And if it's declining or decaying, it's going to be less than 1. And can either be written as a fraction or it can be written as a decimal. Okay? All right, so for part A, we've got this graph right here. And we want to come up with the equation in that form, y equals ab to the x. So the a is going to be where it's crossing the y-axis. So here's your y-axis. What is that point right there where it's crossing? 5. Okay, so you're going to fill in a 5 for the a. The other information we need is what's going to go in for the b. That point right there, I need to know where it's at. Okay, so I just counted over 1 to the right and up 7. So that point is at 1, 7. Okay, I need that information to calculate my b. Okay, so I'm going to use that 7 and that 5 to get my rate of increase. So here's how you're going to do it. You're going to take the 7, you're going to divide it by 5. If you punch that in your calculator, and if you have your calculator out, I highly recommend that you try it. You're going to go 7 divided by 5 equals 1.4. Okay? That means your slope, your graph is going to increase exponentially. Okay? And it's crossing right here at 5. So here's how your numbers get plugged in. The 5, where it's crossing the y-axis, goes in for the a. And the 1.4, which is our calculated growth rate, goes in for the b. And it's always to the power of x. Okay, that's going to give you that exponential growth. All right, let's look at part B. So for part B, we have this graph over here. Zoom in a little bit. And this one, what's happening from left to right? Is it going up or is it going down? It's going down exponentially, okay? So we need to find the rate of decay, okay? So the number that goes in for B, is it going to be greater than 1 or less than 1? Less than 1, okay? And you find it the same way. You're going to take the 40 and you're going to divide it by, is that 120? Yes, 120. And you can either change that to a decimal on your calculator or you can just reduce it because clearly that's a fraction that's reducible, right? 40 over 120 would reduce to 4/12, and 4/12 reduces to 1/3. Okay? So 1/3 is less than 1 whole, right? That means it's decaying or decreasing. The other number that we need is where it's crossing this y-axis. Where's it crossing the y-axis? It looks like 40, right? It looks like it's crossing right there at 40. So that 40 plugs in for A, and the rate of decay, which is 1/3, plugs in for B. Okay? Then you get to question C, and they're trying to trick you. All right? Instead of having an exponential growth or an exponential decay, we've got this flat line, okay? Which we could write in the form y equals mx plus b, but they want us to write it in the form y equals ab to the power of x. Okay, so the a is where it's crossing the y-axis. Where is it crossing the y-axis? Right there. 18. And then, since it's not growing exponentially and it's not decaying exponentially, it's neither greater than 1 nor less than 1, which makes it 1. So we're going to say 18, and plugging in for the b is just 1, and then it's to the power of x. Okay? Kind of a trick question on you there. All right. Question 67 says, Errol and Sandy were working on writing an exponential equation in the y equals abx form using this graph. While trying to write the equation, Errol stated, I think A must be 10 because the y-intercept is at 0, 10. Do you agree? Justify your answer. So you're going to come over and look at the graph. And where's it crossing right there? I put a big point. 10. So you're going to say yes. Errol is correct. The y-intercept is at 0, 10. So when you plug it into the equation, that's going to go in for A. Part B says, but we still don't know what B is, Errol noticed. His teammate Sandy has an idea. I think that 0.0032 equals 10 to the power times B to the 5th power. How did she get this equation? Is this valid? Okay, so there's one other thing on this graph over here. You see it? It's hard to see, but it says there's a point at 5, 0.0032. This is a point, and it's in the form x, some number x, some number y. So she took that number 5, plugged it in for, she took the 5, plugged it in for the x, and she took the 0.0032 and plugged it in for the y. So she just substituted those two numbers in for x, and she subbed it in for y. All right. Part C says, if you have not done so already, use your calculator to help you solve the equation 0.032 equals 10 b to the 5th for b. Explain how you solve this equation. Okay, so here's your b. 2 operations are happening to that b. B is being taken to the 5th power, and b is being multiplied by 10. So we're going to do the inverse operations. What's the inverse operation of multiplying by 10? Dividing. So you're going to divide both sides by 10. So if you have this 0.0032 and you divide by 10, what's going to happen? It's going to make it smaller. It's going to move that decimal where? Over. It's going to move it to the left one spot because we have 1 0. How many ever zeros you have is how many places that decimal is going to move. Okay? So it makes it 0.00032. Okay? Now, the other operation that's happening is b is going to the 5th power. This is a tricky one. What is the inverse operation of, say, taking something to the 5th power? Yeah, it seems like it should be dividing or multiplying, but think about what is the inverse operation of squaring something? Like you take 3 and you square it, you get 9, right? What's the inverse operation that gets you from 9 back to 3? Yes, square rooting, okay? But this isn't a square power, it's a 5th power. Remember how I taught you how to use the caret button last week? Okay, so above that caret button, there's something called an X root. So if you have a fancy scientific calculator, you're going to have this X root button, which is different than just a regular square root button. Square root button is going to take the 2nd root. But we want to take the 5th root, so you're going to type a 5 in first. On this calculator, you have to hit 2nd and then the X root. That's telling the calculator to take the 5th root of that decimal 0.00032, or you could do answer. You know how to get 2nd answer in there. Hit the equal sign, and you're going to get 0.2. Okay? So on your calculator, you would take the 5th root of that decimal 0.000. Oh, I missed a 0 in there. Got to squeeze one more in there. 3 zeros. And then it will give you 0.2. Okay? If you do not have your own calculator, you should practice doing this in Desmos.com. Okay? It'll have a 5th root for you. Your calculator will do it for you too, but it's a little, the calculator on your phone will do it for you too, but it's a little bit trickier to figure out. Okay, plus you can't use your cell phone on a test. You can only use a scientific calculator. So if you have a scientific calculator, definitely practice with it. All right, part D says, use the values of A and B to write an equation for this graph. Verify that your equation is correct and explain how you did so. Okay, this one crosses the y-axis at 10. This one has a growth factor of 0.2, meaning it's going to decay really quickly because this number is less than 1. Okay. Question 68. Use Errol and Sandy's method from problem 867 to write the equation for an exponential function with an asymptote of y equals 0 that passes through the points 0, 5 and the point for 1,280, okay? So you want to take the 1,280, you're going to divide it by 5. So this number divided by this number, that's going to get you 256. But since these numbers aren't consecutive, meaning they don't come one right after another, it's not 0 and then 1, it's 0 and then 4. That means we have to take the 4th root. So on your calculator, you would type in 4th root of 256, hit the equal sign, and it would give you 4. Okay, let me show you how that's done on the calculator, because I just showed you one with the 5th root. So let me show you one with the 4th root. Clear. Okay, so you type in 4, so you want the 4th root. On this calculator, you have to hit 2nd x root of 256, hit the equal sign, and it tells you that it's 4. Okay. Again, if you don't have your own scientific calculator, please practice doing it on Desmos.com so that you know how to do it. All right. Finish copying that down.